Hi everybody, welcome back. This is part 2 of the basic fluid flow simulation using Ansys Discovery. As you saw in part 1, we used the Explore mode in Ansys Discovery to get really fast GPU-powered results to get an understanding of what the flow looks like. Now what we want to do is we want to get a high accuracy solution using our flagship Ansys fluid flow solvers, which are CPU-based, and be able to do things like apply local mesh refinement to get an accurate answer for things like pressure drop and so on. So let me show you how to do that. To go to Analyze mode, simply click here. You'll notice that all the inputs that you provided in the previous video or tutorial, such as the material properties, fluid flow inlets, outlets, and so on, are all preserved. But if you look up at the ribbon, you have access to a few more options, like these advanced simulation options, mesh controls, and so on. So what we're going to do is we're going to apply a mesh refinement, and we're going to do that by clicking local fidelity and then triple clicking on this body here, the fluid domain. Okay. You can also select the fluid domain from the tree right here, but triple clicking is an easy way to select a body. So let's apply a local fidelity control of, let's say, 5 millimeters. So you can just say 5 and mm and hit enter. Okay, and then hit escape to exit the HUD head-up display. You'll notice on the tree we have a fidelity setting that shows up in addition to all the settings that you applied previously. Okay, now if you're wondering what kind of input you need to apply, and of course that is based on experience, maybe some guidance from Ansys. But what you can do is if you just select this radius here, you'll see that this is a 25 millimeter radius. So that means you have a 50 millimeter diameter. So by applying a mesh size of 5 millimeters, you ensure that you have a minimum of 10 mesh elements, which is good enough for this particular simulation. Okay. By the way, just you'll notice that the contours are turned on, so you can turn it off like so. I also want to remind you that the transparency is turned on, so you can always turn that back off or make it opaque by clicking here, like so. You also have access to the cross-section view by clicking Y on the global coordinate system, and then hitting the X key to go into cross-section, like so, and hit D to come back into 3D mode. So there's one more thing I'd like to do. I'd like to apply a monitor, because I want to calculate pressure drop and monitor the convergence of the pressure drop calculation. So my outlet is a 0 pressure. So what I'm going to do is I'm going to click here and then create a monitor. So the variable I'm interested in is pressure, and I'm happy with average, so I'll click a check mark. Okay, so this little box shows up, and what I want to do is click on the details button to show this chart that I'm going to monitor the result as it computes. Okay, so let's hit escape 2 times to exit from here. Now, of course, I can create as many monitors as I want, but I'm really interested in, let's say, pressure between inlet 1 and the outlet. Okay. So I can dismiss this chart. I just want to retain the details chart like this. And that's basically it. I have a couple of other options I can turn on if I want. So under simulation options, you'll notice there are many additional fluid flow options. So for example, things like advanced options like numerical convergence and so on. For this particular example, let's switch from numerical convergence to monitored value convergence. This is a nice advanced feature where the solver automatically stops when the monitored value has reached its final value. So just as an example of the advanced settings that you have in Analyze mode. So now we're done. All we have to do is click the green Solve button. Now, I want to remind you that in Analyze mode, we're using our high-fidelity CPU-based solvers. This is going to solve a little bit slower compared to the GPU solvers in Explore mode, but the results you're getting are higher quality, higher accuracy, and higher fidelity. So this is a good time to take a break, grab a coffee or grab a tea or whatever you like to drink. And then this particular problem should solve, in about 5 to 15 minutes, depending on your computer. Now, one thing you'll notice is a green progress bar, which is kind of going around the simulation information display on the bottom. Once it's halfway around, you can display the mesh, and you do that by clicking here. Okay. So this is using a traditional mesh-based approach. So, people typically want to inspect the mesh and see what things look like on the inside. So let's go back into cross-section mode by clicking on the Y axis in the global coordinate system and hitting X for cross-section. And let's turn on a cut plane by clicking here. And you'll notice that we have a pretty nice mesh. And, we have a lot of intelligence built into Ansys Discovery to automatically refine the mesh in areas of interest like the walls or areas of curvature, as you can see over here. So you don't have to do too much thinking or playing around with these kind of controls, right? So we leverage decades of simulation experience to be able to automate these kind of things for you. So like I said before, this solution is probably going to take about 5 to 15 minutes, depending on your computer. Once the solve actually starts, you'll see this chart updating with a purple line, and we'll use that to monitor the progress of the simulation. So as you can see, this has started, and once this value for pressure reaches a steady state or constant value, the simulation will automatically stop, and you'll be able to view your results and take a look at precise pressure drop values and things like that. So once again, this might take a few minutes, so we'll see you in a couple of minutes after you've grabbed your coffee. As you can see, the solution is progressing pretty nicely. I am running on 4 cores on my laptop, which is the default. Please note that if you have access to more cores on your laptop or your desktop, you can certainly use those if you have the license to do so. This is not using the GPU at all. So for example, if you don't have a GPU and you're not able to use the Explore mode, you can as easily come into Analyze mode and get the same kind of results. In fact, even more results. And the compromises is not as fast as the GPU mode. So it's just a good trade-off, I think, pretty reasonable. So, let's keep watching this result, and the software should automatically shut itself off, or the solve should stop automatically once that pressure value flatlines. So let's just give it a few more minutes. Okay, you can see that's pretty much reached a steady state value, and you can see the green kind of line around the SID has gone all the way around, which indicates that it's pretty much done. So we just have a minute or so more to post-process the results, and then we can take a look at exact values of pressure drop. Actually, at the moment, you can already look at this. If you hover your cursor over this line, it tells you what the pressure drop is. So in this particular case, it's about 2146 pascals. And while I was talking, you can see the results updated. So this is your high fidelity solution for this particular case using a detailed mesh that you see displayed down below. So let's turn off the cross section here, and you can see what that looks like. This is the final steady state solution. You can see the the 2 streams of different temperature fluids mixing as they get past that vein. And just interesting to see how the fluid flow behaves. So this may or may not be an ideal flow distribution at the outlet, or maybe the pressure drop is too high. You can easily make changes to the design, rerun it really quick in Explore mode, and then validate or verify your design in Analyze mode. I just want to point out that if you want to hand this project off to a colleague who is using our expert Ansys Fluent software, you can easily do that by clicking here and then clicking here to export a Fluent file, and your colleague can import this into his or her Fluent software and verify or take your work to the next level. So that's it for part 2 of this video. Hope you enjoyed it. And please make sure to watch the other videos in the Discovery Getting Started series. Thank you very much and have a great day.